In this video, we're going to calculate and compare binomial and normal probabilities. The problem states write the binomial probability and the normal probability for the shaded region of the graph at the right and find the value of each probability and then compare the results. The reason we're going to do this is because when there are certain conditions are met, we can approximate a binomial probability using a normal probability. So real quick, let's go ahead and review binomial probabilities. So a binomial experiment is a probability experiment that satisfies the following conditions. 1. The experiment has a fixed number of trials where each trial is independent of the other trials. 2. There are only two possible outcomes of interest for each trial. Each outcome can be classified as a success or as a failure, which we're going to use P to represent our success and Q to represent our failures. 3. The probability of a success is the same for each trial. And 4. The random variable x counts the number of successful trials. So what we need to do is define our variables or our notation for the binomial experiments, and we're going to use the following. So n will represent the number of trials, p will be the probability of success in a single trial, q is the probability of failure in a single trial, i.e. q equals 1 minus p, and x is going to be the random variable that represents a count of the number of successes in n trials, where x is equal to 0, 1, 2, 3, all the way up to n. Now, we are going to be looking at this histogram over to the right, so let's take a look at that and see if we can identify a few things. First off, we note that we're given the fact that there are n equals 16, which is going to be our number of trials, and we're told that p is equal to 0.5, which means that q will be equal to 1 minus 0.5, which is 0.5. And then we're going to look at the shaded region here, and we see that that encompasses 6, 7, and 8. So what we're trying to find here is the probability of 6 plus the probability of 7 plus the probability of 8. And since the binomial is a discrete experiment, we're going to go ahead and say that we're simply trying to find the probability of 6 less than or equal to x less than or equal to 8. And then we will use our binomial calculations. And this is our formula right here. P of x is equal to n items taken in a combination x times p raised to the x power times q raised to the n minus x power. So just for p of 6, it would look like this. So P of 6 is going to be equal to the combination 16 items chosen 6 at a time times 0.5 to the 6th power times 0.5 raised to the 10th power. Remembering, because P is equal to 0.5 and Q is also equal to 0.5. You'll also note that these two exponents are going to sum to be the n that we're looking at. And I would have to do that for all three of these and then add those together. So instead, what I'd like to do is use some technology. We're going to use Pearson Statcrunch, and it's just a basic platform that comes integrated with your textbook, and you can also purchase access to this. This is probably one of the more basic statistical analysis programs out there. It's on the web, but it's similar to using Excel, but it already has predefined functions where you just use drop-down menus. So what we're going to do is we're going to look at Statcrunch real quick, and then we're going to simply go to Stat and go to Calculators. And you'll notice that Binomial is right here. So if I left-click Binomial, it gives me a calculator, which is already set up for me to just enter information. Now, we're going to be doing a between from 6 to 8, which is what we have right here. Okay? So let's go ahead, let's look at our Statcrunch, and then we will go ahead and do some calculations. So this is a between, so we'll left click between. We're going to enter n, which we already know is 16. We're going to enter p, which is defaulting to 0.5, and then we're going to go from 6 as our lower value up to 8 as our upper value. Sorry, that should be 8. There we go. And left click compute, and this right here, rounded to 4 decimal places, is our probability that we were trying to calculate. Okay, now what we're going to do is we're going to perform the same search or calculations for probability, but we're going to use the normal probability. We're going to assume that we can use a normal probability to approximate the binomial probability in this case. And the reason for that is because I'm going to make a couple of calculations to see if I can use the normal distribution to approximate the binomial. So in this case, we want to use the following two tests. We want to find and multiply n times p and determine if they're greater than or equal to 5. We're also going to do n times q and determine if that's greater than or equal to 5. Remember, this is going to be a normal approximation. So let's go ahead and do those calculations, remembering that n is 16 and p is 0.5, so I have 16 times 0.5. You calculate that, and that's going to be greater than or equal to 8, and is that greater than or equal to 5 is what I'm trying to say. And 16 times 0.5 is 8, which is in fact greater than or equal to 5. So I'm halfway there. So let's go ahead and do n times q, which in this case, since p is 0.5 and q is going to also be 0.5, we're actually going to end up with the exact same answer. We'll have 16 times 0.5, and we need to confirm that is greater than or equal to 5. And in fact, 8 is greater than or equal to 5, so we can use the normal. And in order to do that, though, we need to know what the mean is, and we also need to know what the standard deviation is. So we're going to introduce two new formulas. When we're approximating the binomial using the normal distribution, our mean mu is going to be equal to n times p. But you'll notice that we've already calculated that when we performed the first test to determine if n times p was greater than or equal to 5. So that means our mu is equal to 8. Now the standard deviation sigma is going to be equal to the square root of n times p times q, which in this case is the square root of 16 times 0.5 times 0.5. And you can just go ahead and plug that into your calculator, and that will give us a value of 2. And so once again, I can go ahead and I can use the binomial and do all the calculations, but since we've already used technology once, let's go ahead and use technology again. We're going to go right back to Statcrunch. We're going to use the binomial calculator that's integrated into that. So here's Statcrunch. I'm going to slide this over a little bit so that I can see my mean and my standard deviation. In fact, let me go ahead and just rewrite it up here. And so the mean is equal to 8 and the standard deviation is equal to 2. Now, before I bring Statcrunch back in, let's talk a little bit about what we're going to have to do with the normal, okay? Binomial is discrete, normal is going to be continuous. So what we want to do is actually start right here to the left of our value 6 and end to the right of our value 8. So in reality, what we're trying to do is find the probability of 5.5 less than or equal to x less than or equal to 8.5. once again, I can go ahead and I can use the binomial. I can calculate a z-score, calculate z-scores, find associated areas, and subtract the smaller from the larger. But like I said, we're going to use technology. And the reason I want to use Statcrunch is that I can put the two calculators basically side by side, and I can look at what they're doing or how they compare. So let's go ahead and go back into Statcrunch. Let me move this down or over. Tell you what, let me make my window a little wider so that I can move this. And once again, I'm going to go to Stat. I'm going to go to Calculators, but in this case, instead of binomial, I'm going to scroll down until I can highlight normal and left click that, and that's going to give me another calculator. So we'll go ahead and once again, instead of using standard, we're going to use between. Now we've calculated the mean to be 8, so we'll enter that. We've calculated the standard deviation to be 2, and we're going to find the probability from 5.5 up to 8.5. Then we simply left click compute, and you'll notice that the probabilities are virtually identical. There's very little difference between them. And if we go ahead and simply round this one to 4 decimal places, it would be 0.493. So let's do that. So the probability is equal to 0.49, and I forgot what it was, but that's okay because it's the same thing as we got up here, 0.4931. And so let's compare that. The first one's going to be the binomial, and that's the probability going from 6 to 8, and we calculated that as 0.4931, and this is the normal. Using technology, we calculated that to be 5.5 up to x up to 8.5, and that's also equal to 0.4931, and therefore what can we say about it? The two methods produce virtually identical answers. Now keep in mind that while using technology is great, we still have to understand the concepts behind it. I know plenty of people that love to instantly go to their calculator, but a lot of times they'll come up with an incorrect answer because they're not truly understanding the process and how they're inputting it into the calculator. So if you have any questions, just let me know.